In this video, we'll be learning how to rewrite an equation into what is called function form.
So the first thing you might be asking is, what on earth is function form? And function form is when an equation, specifically one that has two variables, is rewritten so the y value is alone. So we're going to look at how we can rewrite equations so that they have the same meaning, but so that they look a little bit different and the y value is alone. So for example, if you look down at the example below, you'll see we have 3x plus y is equal to 7. Now if we reread our definition of function form, we can see that we want to rewrite this equation so the y value is alone. So what that means is we want y by itself on one side of the equation completely alone. So we want it to look something like y equals, and then we want it equal to something. So that's going to be our goal. So we need to move terms entirely away from y. So for example here, you'll notice that 3x is being added to y. Now we want y to be completely by itself. So what we have to think about is how on earth we could get the y value by itself by undoing that entire 3x. And what I notice here is that these two items are being added together. So if I want to undo an addition, I know that I undo an addition by using subtraction or by adding a negative version of that number. So here, if we add negative 3x, or you can think about it as subtract 3x, but if we add negative 3x or subtract 3x from each side, this actually becomes 0. 3x plus negative 3x is a 0x. And then we have to do that same thing to the other side of the equation. So here, this becomes 0 and cancels itself out. So we're left with just y. So we have y equals, and then on the right-hand side, we have 7 plus negative 3x. Now, some of you might be wondering why I didn't write 4x. And if we look carefully, what we see is that this term contains an x, and this term does not. As a result, those are not alike terms and cannot be combined. So, by adding that negative 3x to each side, we have now rewritten this equation so that y is alone. So notice that we just used some of our undoing rules to get y completely by itself. So this original equation written into function form when y is alone is y equals 7 plus negative 3x. So what we're going to do in the rest of this video is we are just going to practice rewriting these equations into function form. And remember, that's the form y equals, and then you have something on the right-hand side. So we're going to work on getting it into y equals form. And they're going to get progressively harder as we go. But here, let's start with this next one. We have y minus 2x is equal to 9. And what I see here is I see a subtraction, so I'm going to turn this into a keep, change problem right away so that I don't make a mistake with that subtraction. And then from here I notice that I want to get y completely by itself. And what I see happening is I see y being added to a negative 2x. So I realize that in order to get y alone, I have to undo this addition of a negative 2x here. And the way to do that is by adding a positive 2x to each side. Notice that negative 2x plus 2x, so they are opposite of each other. When we add those together, they completely cancel out. Now remember, whatever we do to one side of the equation, we must also do to the other. So we also have to add that 2x to the right-hand side. So if I add 2x to each side, I end up with y alone on the left is equal to 9 plus 2x on the right-hand side. And then when I look, I notice that 9 does not contain an x, but this 2x does. Because of that, they're not alike terms, so I leave them as is, And my equation, rewritten in function form, is y equals 9 plus 2x. So now let's make this a little bit harder. So here we notice that we have negative 8x plus 2y is equal to 12. And again, our goal is to get this y value here completely alone. That's what we want to be by itself by the end of this problem. But I notice that there's multiple things in this problem now. There's a negative 8x and then there's that 2 attached to the y. So what I always suggest doing is you always need to get rid of anything that's not directly attached to the y first. So what that means is we need to focus on this negative 8x and how we're going to get rid of that first. How we're going to undo that to the other side of the equation. Now remember, I want to completely zero it out, and the way to do that is to add 8x to each side. Notice that when I add 8x to each side, we have negative 8x plus 8x, and that becomes 0. So those are going to zero out. Now whatever I do to the left-hand side, I also have to do to the right-hand side of the equation, so I'm going to add 8x over there. So right now, what I'm left with is I have 2y on the left-hand side, because negative 8x and 8x undid each other, is equal to 12 plus 8x. Now, this problem is a little bit trickier because there's a 2 attached to the y. And we still want to get y completely alone. Remember that. We want y completely by itself. So what I realize here is if I want to undo this 2, I notice that there's a multiplication symbol implied between the 2 and the y. So in order to get the y by itself, I need to divide by 2 to undo that multiplication. Now what that also means is I need to divide everything on the other side of the equation by 2 as well. So I divide 2y by 2, so these cancel out, and I'm left with y. I then have 12 divided by 2, which is 6. 8 divided by 2, which leaves me with 4 times x. And now we're completely simplified. And then notice I can't add the 6 and the 4x together because they aren't alike terms. So notice here that we undid the negative 8x first by adding 8x to each side, and then we divided everything by the 2 that was in front of the y. So here we have our final answer of y equals 6 plus 4x. All right, moving right along. So here we have 9x plus negative 3y is equal to negative 12. And again, my goal is to get this y value completely by itself. Now to start, I always want to utilize keep, change, change so I don't make any errors. So I change this to 9x plus negative 3y is equal to negative 12. And remember, my goal is to start by getting rid of this x term. So I want to get the y by itself eventually, so I start with the term that's not really associated with y at all, which is 9x. Now to undo that 9x completely to the other side, I have to undo a positive 9x, which I do by adding a negative 9x to each side. So notice 9x plus negative 9x, and that becomes 0. So those completely cancel out. So on the left-hand side, I'm left with negative 3y, and on the right-hand side, I'm left with negative 12 plus a negative 9x. And notice those can't be combined because they aren't alike terms. Now from here, I need to get the y completely by itself, which means I need to undo this multiplication of negative 3 taking place. So I'm going to divide every single term by a negative 3. And as a result of that, we end up with y is equal to negative 12 over negative 3 is a positive 4, plus negative 9 over negative 3 is a positive 3x. So we now have y completely alone. So to start this problem, I notice that my x and my y are changed a little bit. So this is emphasizing how important it is to slow down and really read this equation here. So here we have our y value that we want to get by itself. We also notice that we want to utilize keep, change, change here to prevent ourselves from making an error. So we want to get that 5y by itself first. So our goal is to undo this negative 15x. So we're going to start by adding 15x to each side. So by adding 15x to each side, my goal is to undo that negative 15x, which I do because negative 15x plus 15x is equal to 0. So we now have 5y is equal to 35 plus 15x. Now remember, my goal is to get y completely alone, so I want to undo what's happening to y, which is a multiplication of 5. So I'm going to divide everything by 5 here. Now, I know I wrote this a little weird. That big division of 5, you can also write it as 35 over 5 and 15x over 5. Either way is okay. So we have 5y over 5, which is just y, is equal to 35 over 5, which is 7, plus 15x over 5, which is 3x. So this example is a little trickier. Here, the first thing I notice is that I have a keep, change, change situation, so I want to utilize that right off the bat. And then I notice that my goal is to get this y by itself by the end of this problem. Now, what I notice first is that x doesn't have a coefficient, but I remember that an x without a number in front of it really has an implied 1. So I'm going to draw my 1 in there so I do not forget that it's there. Then I want to undo this x term to the other side of the equation, and the way to do that is by subtracting 1x or adding a negative 1x to each side. So remember, our goal is to move this x to the other side, and we do that by doing its opposite. So we're going to add a negative 1x to each side so that these will cancel out. So we're now left with negative 5y is equal to 10 plus negative 1x. Now, my next step here is I want to get the y completely by itself, which means I need to undo this multiplication here by utilizing division. So I divide each side, or everything, by a negative 5. So here I end up with just y on the left-hand side. 10 over negative 5 is negative 2. And then this one's actually a little bit tricky. You might be tempted to write 5 here, but notice that 1 is in the numerator. And if you did 1 divided by 5, you're not going to get 5 if you try it in your calculator. You're instead going to get 0.2. So what we're going to do here is we're going to leave it as a fraction. Now, first thing I note is I have a negative divided by a negative, so I know my answer is going to be positive. And then I'm just going to leave my fraction as is. I'm going to leave it as 1 over 5x. So if it doesn't simplify to some nice integer, you can just leave it as a fraction. So here we have y is equal to negative 2 plus 1 over 5x. All right, next example here. Again, our goal is to get y completely by itself. Again, we start off with keep, change, change. And then we notice that we need to move that 3x to the other side. So hopefully you're already thinking that you can undo that negative 3x by adding 3x to each side. So we add 3x to each side, so we end up with 7y is equal to 28 plus 3x. Then from here I'm noticing that I want to get y completely by itself, so I need to undo that multiplication of 7. And I undo that multiplication of 7 by dividing both sides by 7. Remember, the other way to represent this is just to divide every term by 7. So we'll do 28 over 7 and 3x over 7. So we're dividing everything by 7. And ultimately we end up with y on the left-hand side. 28 over 7 gives us 4. Plus 3 divided by 7 isn't a nice number. So we're going to leave that as the fraction 3 over 7 times x. All right, 2 more examples to go. So here I notice that I need to utilize keep, change, change. So I have plus a negative, and then I notice that y doesn't have a number in front of it, so I'm going to give it a negative 1, because that's a number that's going to be there if there's not a number in front of y. So here we have 8x plus negative 1y equals negative 10. So my first goal is to move this 8x and undo it to the other side. So hopefully you're already thinking that you're going to subtract 8x or add a negative 8x to each side in order to do that so that these become 0. We're then left with negative 1y is equal to negative 10 plus negative 8x. Now in order to undo this multiplication of negative 1, I need to divide both sides, or divide every single term, by negative 1. So negative 1y divided by negative 1 is just y. Negative 10 divided by negative 1, we have a negative divided by a negative, so that's a positive 10. And then negative 8 divided by negative 1, again, it's a negative divided by a negative, so that's a positive 8x. So notice the trick in that one. If you see that negative in front of a y, make sure that you turn that into a negative 1 coefficient so that you remember to divide by negative 1 at the very, very end. And our last example. So here our goal is to get y alone still. So remember that we need to start by getting the x term to the other side of the equation. So we're going to subtract 6x or add a negative 6x to each side so that these become 0. And we're left with 5y is equal to 12 plus a negative 6x. We then need to get y alone, and we can see that we are multiplying by 5 here. So in order to get y alone, we're going to divide everything by 5. Remember, that means I can write it as little mini fractions too. So I can write 12 over 5 and a negative 6x over 5. So then from here, I just need to divide. So I get a y on the left-hand side. I notice that 12 and 5 don't really divide nicely, so I'm just going to leave those as a fraction. And then here I notice that negative 6 over 5 also doesn't divide nicely, so I'm going to just leave that as negative 6 over 5x.